We are reviewing for your accounting principles test coming up, and what we're looking for first is just answering these questions based on numerical values. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1, which is 720. For this one, 8 factorial over 5 factorial. That means if I were to write these out, you would have 8 times 7 times 6 times 5 all the way down, and then for 5 factorial, 5 through 1 all the way down. Well, the 5 through 1 are going to cancel each other out because they're on the top and bottom, leaving you with 8 times 7 times 6, which is 336. 0 factorial, this is just a special case. This is like you're ordering no objects. Well, there's only one way to order a set of nothing, so you have to say one way. There's not no ways to order nothing. There has to be at least one way to do it. Okay, with the binomial, 7 choose 4. Remember, that means you put the top number up top with a factorial, the bottom on the bottom with a factorial, and then we subtract them and also put that on the bottom with a factorial. And then we need to just try to simplify that. Well, same thing is kind of like we did up here. We would have the 7 would cancel with the 4. You would leave 7, 6, and 5 up top, and you still have the 3 factorial, 3, 2, and 1 on the bottom. The 6 can cancel out with the 3 and 2, so you have 7 times 5 up top, and then just a times 1 on the bottom, giving you 35 for your answer. Number 5, what you should look at here, there's 2 different ways you can look at this. If you try to do it mathematically, you'd have 1441 factorial over 1 factorial and 1440 factorial. What you should notice is that everything, if you were to write this whole thing out, which please don't try to do that, the only thing that you would be left with would be the 1441, because from 1440 down, well, that's 1440 factorial. So all you'll be left with is 1441 over 1. Now, the other way to think about this means the way to choose one person from 1,441 of them. Well, the way to choose one person from any number is just to pick one of those numbers. So no matter what, if you have something choose 1, the top number is always your answer. Same thing here with 9 choose 8. If you're 1 away, it's always just, again, going to be the top number. This means of 9 people, choose 8 to be on a committee. That's the same as saying of 9 people, choose 1 not to be on the committee. And if you don't trust yourself with that, you can again go back to this idea, and the same thing. The 8 factorial will take away everything below 9, leaving you 9 over 1, which is also 9. For this one, 3 choose 0. Kind of like with 0 factorial. The only way that you can choose 0 objects is just the empty set, the empty choice of objects. So it's the answer 1. Okay, 5 choose 6. If I have 5 people and I want to choose 6, can I even do that? No, I can't. So that's why you can never have a number on the bottom that's bigger, so there's no solution for that. And in number 9, to find this missing number down here, something to take a look at back from number 4. 7 choose 4, we had 4 and 3 on the bottom. If I made this a 3, it would have been 3 and 4 on the bottom in the same order. So the only way to do this is by taking the 8 minus 3, subtracting them, and that's the number on the bottom. So your missing number is equal to 5. And again, to prove that, you'd have 8 factorial over 3 factorial, 5 factorial with this one. And with the new one, you'd have 8 factorial over 5 factorial, 3 factorial, which is the same exact thing. Alright, looking at this one, we're saying if it's a permutation or a combination. Remember, permutation means that order matters. Combination means that order does not matter. So things that order would matter in would be like finishing in a race. Order does not matter in like picking certain like captains for a team or ways to form a committee. And perfect, right off the bat, number of ways to form a committee. It doesn't matter if I pick Johnny first and then Susie or vice versa. So that is a combination. Number of ways to create a password. Well, the order of your letters in a password will matter. That makes it a permutation. Seating arrangements. Well, it's going to matter if Johnny sits in seat 1 versus seat 2. So that is a different arrangement. So yes, that is a permutation. Poker hands. It doesn't matter what order in my hand my 5 cards are. That makes it a combination. Choosing captains. I have 3 captains. It doesn't matter really how many. But what it's saying here is that it doesn't matter if I pick Robbie as the first captain or if I pick Johnny as the first captain. They're both equal, same captain. And then the number of entries for a combination lock. This is going to try to confuse you just because it's a bad choice of words. Combination locks are ones where you have, 3 different numbers. And it matters, like if your combo is 10, 70, 32, It matters if you go 10, 70, 32 versus 10, 32, 70. So these are two different ideas. Order matters, permutation it is. Alright, in these ones, we do not need to find a numerical answer, we just need to show some way of identifying what the mathematical expression is to find an answer. So in this first one, creating an ID number. Well, ID numbers are like a passcode. It matters what the order is. So I'm going to start by making my set of my list of 9 numbers in a row. Okay? And then it gives us these restrictions. The first thing it says is that the first number must be a 9. This guy must be a 9. How many ways can I do that? Well, there's only one possible way to make a 9. It's by putting a 9 there. Now, there must be exactly 2 3s. Question is, where are they? Well, if I put a 3 here and here, that's the same as if I flip-flopped them. So I can't say just a perfect permutation right now. But what I can say is, of the 8 spots that were left, I needed to choose 2 of them to have the 3s in them. So I can do that by saying 8, choose 2. And then that leaves me with 1, 2, 3, 4, 5, 6 spots left. Each of the 6 spots can have any possible number in it, so you have 10 digits. However, I can't have any more 3s. I only had 2 of them. So that means that everything the rest of the way only has 9 options, because it can be anything 0 through 9 except for 3. So I have 9 options for each of these guys, which means this is 9 to the 6th power, or 9 times 9 times 9, 6 times. So this right here would be your full answer. And again, you do not need to find the actual numerical idea. Okay, we talked about number 17 already. Captains, it doesn't matter the order. I have 15 players to choose from. I need to choose 3 captains. 15, choose 3, just that simple. Alright, spellings of a word. Order matters in spellings of a word. So, we have the word mathematics, which has 11 letters in it. So I'm going to make 11 different letter spots there. And now, if they were all different letters, I can't think of a good one right now, but even if you just said, the word like flag has all different letters, this one would be just 4 factorial. I have 4 choices for the first letter, 3, 2, and 1. However, in this case, we have a couple that are duplicates, kind of like the 3s up here in number 16. So what I'm going to do is I'm going to place all my duplicate letters first. So I'm going to place the M's first somewhere. So I'll place one M there and one M there. How do I choose those locations? Well, I have 11 spots. I have to choose 2 of them to place the M's. So that's how I place where my M's go. Let's now go with the A's. So I have to place my A's somewhere. I had 9 spots remaining, and I need to place my 2 A's. So I do that with 9, choose 2. Let's place the next letter in our set. The next letter we have to deal with, the next letter we have to deal with is T's. I have a pair of T's. So let's say one T goes there and one T comes down here. So I had 7 spots left at that point, and I had to choose the 2 of where the T's would go. Now, all the guys that are left, the H, E, and I, C, S, 5 letters left, and they're all different letters. That means that I have 5 choices then for my first letter, 4 then for what's left, then 3, then 2, then 1, or 5 factorial. So that's how you can place, there's your final answer. That's how you can create how many words there are. So again, the pink part came from the M's, the red part came from the A's, the blue part came from the T's, and then the green part here came from the rest of them. Alright, moving on. 19. He has 7 different shirts, 4 different pants, 10 different ties. How many outfits did he create? Well, just go one part at a time. These are steps, so we're thinking multiplication still. 7 different shirts. Well, he has 7 shirts. He can only choose 1 to wear, so 7, choose 1. For 4 different pants. 4 pants, he's got to choose 1. 10 different ties, he has to choose 1. That's your answer. Now remember, also, when you choose 1, that's the same as just saying 7, 4, and 10, just their numbers on their own. There's a number of ways to choose one guy out of 7 things. there's exactly 7 of them. So either one of those are valid answers. Now, number 20, from a deck of 52 cards, how many poker hands, I should say this is a 5-card poker hand, can you create so that you have 3 of the 4 aces in your hand? Well, there's 4 aces. I need to choose 3 of them to be in my hand. So that's the way to start, is I need to place what I know with my aces. Now, there are 2 cards left to be placed. So let's start with that. I know I need to choose 2 cards. How many of them are left to deal with? Well, we have 49 cards left in the deck, but we don't want this other ace either. We don't want any of the 4 aces. We can take any of the other 48 cards. So this is for the other cards in your deck. And then that's your answer, just like that. 4 choose 3 times 48 choose 2. Alright, now, part about the musical cast. This is where we might get a couple dealing with some cases versus some steps, all the above. So, first part here. We need to create 2 committees. We need a costume committee and an after-party committee. The costume committee has 8, and the after-party committee has 10 people. So, there are no restrictions, first off, in the first idea. How many ways can the committees be formed? Well, for the costume committee, there's 35 people. I need to choose 8. Remember, committees, you're thinking this binomial idea of choosing people. So this is for the costume committee, but then we also need the after-party committee. Well, there are 35 people. I need to choose 10 to be on that committee as well. So that's the way to make it with no restrictions whatsoever. And number 2, if no student can serve on on both committees. So meaning we have to have different people, a different 18 people to serve on the committees. Well, let's first make the costume committee, which we said was 35, choose 8. Now, those 8 cannot go again. So I only have 27 people left for the 10 people to serve on the after-party committee. So there is your answer. Now, we have another possibility. I could have made the after-party committee first. So I would have had 35 choose 10 for the after-party committee, and then I would have had 25 left and choosing 8 for the costume committee. So both of those answers are valid and correct. In 23, after-party committee also needs a president. So we're going to start by first making our committees like we did before. There's no restriction, so it should start the exact same way as number 21 did. So we had 35 choose 8 and 35 choose 10. Now, however, we need somebody to serve as the president from the after-party committee. This one was the after-party committee, so all I need to do is pick one of these 10 to serve on that committee. So I'll multiply by 10, choose 1, or just 10. Because of those 10 people, I need to choose 1 in there to be the president. Okay, if exactly 2 or exactly 3 cast members sit on both committees. Well, this right here should throw up a big red flag. We're going to have 2 different ideas here. So I'm going to have a case with 2 people, and I'm going to have a case when I have 3 people. Okay? Whenever you have something that is given to you like this, the first step I should say is to, as you're solving it, when you say or when you get any of these with exactly 2, exactly 3, any of that, place the guys that you know. Take care of the things that you know first. So in this case, you know that there are exactly 2 people in case 2 who are on both members. Well, let's find those 2 people. Of the 35 people, I'm going to choose 2 to be on both committees. From there, I now need to place the rest of the after-party committee. Or let's do the costume committee first. That's what we've been doing first. So there's 33 people left, and I need another 6 more to fill up the costume committee. And then for the after party, I have now, there's no other restrictions. Or no, there are restrictions. Because if I pick 33, choose 8 for the after party committee, I have the chance of people who are still sitting on both committees. I only wanted there to be 2 of them. So 33 is not what we want. We need to have how many are left, which is 27 choose 8. Same thing here with the case with 3. First place, both people who are on both, which is 35 choose 3 this time, because we want 3 people on both committees. Then, let's figure out the rest of them. Costume. There's 32 people remaining, and we need 5 more spots on that committee. And then we also need the after-party committee. There's 27 people left. I need 7 more to fill up the 10 people on the costume party committee. Now, your final answer, when we do cases, we need to take these two numbers that we found and add them together. So I'm just going to rewrite it over here. 35 choose 2 times 33 choose 6 times 27 choose 8. We need to add that with the 35 choose 3, 32 choose 5, and I'm running out of room, 27 choose 7. Try to scrunch that down a little bit here. Okay, so 35 choose 3, 32 choose 5, and 27 choose 7. This whole thing added up is your answer. All right, and the last part, the lead actor and lead actress are on separate committees. Okay, so something that, this is probably the toughest one on here that might be tough for you to think. We know that the actor and actress are on different committees. Let's get them placed first. How many choices does the lead actor have? Well, the actor can be either on the costume committee or on the after party committee. So this is if the actor is on the costume and if the actor is on the after party. So if he's on the the costume committee, that means then that the actress has to be on the other committee. So those two are already placed and done with. There's only one way we can do that. We're forcing him to be on this committee, therefore she has to be on the other committee. That means there's 33 people left. We need to fill out the costume committee first, and there's 7 different committees left to go. Now, is there anything about people sitting on both committees? No, there's not. Just that these two obviously can't be on both because they have to be separate. So there's still 33 people. We need 9 more to fill out your after party committee. Now, if the actor's on the after party committee first to begin, that just means the lead actress is on the other one. So we're still going to have 33 people to choose from. We still need 7 more for the first, and we still need 9 more for the second. So with these, in these cases, I'd be adding them up. Now, there's another way you could solve this that actually I just thought of. First thing you can look at is, well, how many choices do we have first for the actor? Well, he has 2 choices between the costume or the after party. So he has 2 choices, or 2 choose 1 if you prefer. Then, how about the actress? So when I say and, I'm multiplying. The actress, well, she only has 1 choice. She has to be on the other committee. So there's only 1 choice for the actress. So now she's done. So now we need to fill up the rest of the after party committee and the rest of the costume committee. Or let's do the costume committee first like we've been doing and the after party committee second. We still have 33 people. We need to choose 7. And we still have 33 people and we need to choose 9 for the after party. So as you can see, I have the exact same answer because I have 2 times this binomial multiplication and I had the same binomial multiplication added together twice. So each of those are valid, legitimate answers. Alright, last one here. We need to prove that the above equation is true. First, algebraically. Well, I have 16 times and then this binomial, which is 20 factorial over 16 factorial, 4 factorial. With this guy on the right, it's 20 factorial, or not 20 factorial, sorry, 20 times 19 factorial over 15 factorial, 4 factorial. Alright, what I'm going to try to do is simplify each of these sides a little bit. This one I think is easy to see. If you have 19 factorial, that's 1 through 19. But I'm also tacking on 20, so that's 20 factorial. And I'm just going to keep the bottom the same, 15 over 4, or 15 factorial, 4 factorial. This one here, I have a 16 on the top and bottom. They would cancel out, leaving me with just 15 factorial. Well, that means I have 20 factorial up top, 15 factorial, and 4 factorial on the bottom, which are the exact same. If you want to go and try to find numerical answers for both of these and give that number as your answer, that's a fine way to do it as well. Now, when it says combinatorically proved, that means you need to give a collection of objects for both the left-hand side and for the right-hand side. Okay? In this case, when we have a binomial, think committees. Well, this 20 choose 16 represents how many ways to form a 16-member committee from from 20 people. So from 20 people, I'm making a committee with 16 people on it. And now, the number 16, that's like saying, okay, of those 16 people, we need to choose a president from the 16 people. So what this is saying is, this is a way of making a committee with 16 people on it from the 20 people and naming one of them president. Now, the right-hand side needs to do the exact same thing, needs to describe the exact same object. Well, there were 20 people to begin with, so use that to help you. The 20 would represent, okay, of the 20 people, choose the president first this time. So of the 20 people, choose one. So choose the president first of the 20 people that we can choose from. And that means that he's on the committee, he's the president of the committee. That means left, now the 19 choose 15, well, that's one less person because we've already put the president on the committee. We need to now choose 15 more to fill the committee from the 19 remaining candidates. So, what you just did, you just proved that both sides represent making a 16-member committee with one person named the president. You just did it in two different ways. This one we made the committee and then named the president. This one we named the president and then filled out the rest of the committee. That's what you need to say. You need to say exactly what you are finding. We're finding a 16-member committee that is given a president out of a group of 20 people, and then you need to prove why each side of that equal sign proves that equation. There you have it. Best of luck and count well.